Today, I'm going to talk about a project where we build a model to predict whether a patient might have cirrhosis, which is a liver disease. And first thing first, we're gonna install and import all the necessary things we are gonna need for the analysis. We're gonna start with what we did to get the data ready and train the models. The dataset have 418 patterns and 20 features, include details like age, sex, and the liver-related test result. And we can see here there are a lot of empty values, and we are gonna deal with this later. And also we can see that uh, this columns is not really necessary for the training process. So we're gonna do some cleaning here. So we are here at the pre-processing part. First thing, we are gonna make sure we don't have any missing values. So missing values both the numerical features and the characteristical features, we're gonna fill them with zero. And this approach handle missing value data, allowing the model to proceed the data without any errors. And from the previous part, we can tell the original stage variables with four categories, which is one, two, three, four, and we're gonna transfer them into a binary target. For example, no represent no cirrhosis, and one represent the patient might have cirrhosis. This simplifies the classification tags to a binary problem, making it suitable for machine learning algorithm. Here we have our skewness analysis. Skewness of numeric feature were addressed using a logarithmic transformation for variables with high skewness, and this reduced the effect of extreme value and make the data more even distributed. This will help the model perform better, especially for those sensitive to skewed data. And here we have the outliers handling. Outliers is a numeric feature were handled using winsorization technique, and this technique limited extreme value to a certain percentile, reducing the influence of outliers on the model while preserving some information from this data point. Now I will explain why we use these specific models and how they are well suited for this problem. And to solve this problem, we use a mix of techniques and models to make sure our predictions were as accurate and as reliable as possible. We use PyCard here. That's a tool that automatically tests machine learning models instead of manually run each model one by one. PyCard will compare them for us and tell us which one performs the best. This saves us a lot of time and ensuring we are using the right models for the job. For this dataset, it helps us identify the best model without guesswork. One of the models we test and included a pipeline was decision tree. Decision tree are the great because they are easily to understand and don't need us to worry about scaling or standardizing the data. They also work well when we have both numbers and categorized in our data. Decision tree split the data into smaller, which is perfect for the problem with a lot of variety in the future. Our datasets have an imbalance. If we trained the model without fixing this, it might ignore the smaller classes. To fix this, we use a technique called SMOTE. It creates new and synthetical example for the smaller class to balancing out. By giving the smaller class more weight, it helped the model pay attention to all the data equally and making prediction fairly and more accurate. To make sure our model were reliable, we also use cross-validation. This technique split the data into multiple parts and train the models on different combination of this part. In this way, we can see how well the model work across the entire dataset. It prevent overfitting, meaning the model didn't just memorize the training data. Finally, we combine all this data into a pipeline. The pipeline make it easy to process the data, balance it, and train the model in one go. This reduces the chance of errors and keep everything consistent. In short, we use PyCard to choose the best model, decision tree for simply and interpretably, and small to handle class imbalance and cross validation to ensure reliability. Together, these techniques give us a strong, fair, and accurate model to solve this problem. Now we talk about what we learned from the result and how they can be applied in real life. The decision tree classifier and PyCar's best model performed well, showing good accuracy and positive result in their confusion matrix. This indicates that machine learning models can successfully predict the stage of uh, the liver disease using clinical data. And if we were gonna use this in our real life, this model could help doctors predict cirrhosis earlier and assess risks more accurately and enable timely treatment and better patient outcomes. Insights from the model could aid in understanding the cause and the progression of cirrhosis, and it opened doors to new treatments and diagnosis tools, I think. By predict the disease stage, the model could help the trader treatment to fit the needs of each patient and leading more effective care for the patient. And it also can identify patients who are at high risk, and we can help them to provide a better healthcare efficiently and improve care quality while reducing the cost. That's all for today's analysis. Thank you for the listening.